We are working today with the deflection of a beam under load. Typically what we're doing is looking at two conditions. One, where the beam is rigidly supported on one end, loaded along its axis, where we get a bending along its axis. Second condition we're looking at is where it is supported at 2 points along its way, and when that's loaded, there will be a deflection in the middle that's going to be different from the beam in cantilever where it's supported at 1 point. So we'll get to observe both of those conditions. We have several different materials. We have steel, brass, and aluminum. Each of them has a different elastic modulus. Was supported for the first experiment on one end, and this clamp is holding it such that the interface at this end, where it comes out of the clamp, is at 0 on a scale along the top. Everything is in metric. So right now our point of reference is 0 millimeters, and part of the experimental setup is a dial indicator settable to 0 at our point of reference where we have no load on it. We can move this along the axis of the beam to measure deflection at various points along the way. So for our first experiment, we will set the indicator based on the scale on the top, 200 millimeters from the point of support. Set that to 0 deflection. So we'll add point load to this in 100-gram increments. I have several of these preset at 100 grams, 200 grams, 300 grams, all the way up to 500 grams. So we'll take 5 different readings on this. Start by putting a 100-gram load and my deflection is 1.18 millimeters. So we'll record what that is. You go to table 1 on your experimental worksheet. Release that, bring that back to 0, and then put a 200-gram load on it at that point, carefully. And my deflection is 2.17 millimeters. the same thing with a 300 millimeter load, a 300 gram load. And my deflection 3.17. To increase the level of the load, go to 400 grams. What am I doing wrong?
You're pushing down.
Deflection of 4.07 millimeters. And with 500 grams, our deflection is 5.09. So our deflection is increasing more or less linearly. We'll go through and do the calculations for this after we do the other test, but this is aluminum, so our elastic modulus is 69 times 10 to the 9th newtons per square meter. My second moment of inertia. Okay, we have run 5 different loads in cantilever on an aluminum beam, and we will provide you with the information from this and from the same experiment performed on a brass and a steel beam. And we'll look at how the difference on those in deflection under the same conditions happens because of the different elastic modulus of the material.